I'm Saritha Kumari, Assistant Professor, Institute of Aeronautical Engineering College, EEE Department, Hyderabad. Today the topic is overhead line supports. So it is mapped to course outcome 2. So before going to the overhead line supports, what are the various types of supporting towers used in transmission lines, overhead transmission lines. So before that, first see about these two subparts. What is the first one is stringing chart. So the stringing chart, you can see on the left side, there is a graph. So it is called a stringing chart, which basically it is a graph between sag versus temperature and tension versus temperature. So stringing chart is basically a graph between sag versus temperature and tension versus temperature. So it is plotted for a fixed span. So we can see on the down. So the temperature is taken on the x-axis and tension on the y-axis. Here you can see tension in kgs. So what happens if the temperature go on increased? What happens? Correspondingly, the tension get decreased. Okay, the tension, if temperature increases, the tension goes on decreases, because with temperature the conductor length little bit increased. So then automatically the conductor is the tension, the pressure on the conductor is going to be reduced. Next, sag versus temperature. On the same graph, if we take sag on the other side, on the y-axis, sag in meters. So what happens? See that we see here the sag also decreases with increasing temperature. Why? Because we know that sag expression is WL square by 80. So it is inversely proportional to tension. Sag inversely proportional to tension. So here in the same manner, sag also reduces with temperature. Okay. So that is the graph. So the graph shows that sag also reduces with temperature. So stringing charts, what is the use? Stringing chart in erecting the transmission line conductors for adjusting sag and tension, and in the design of insulator string, and in the design of tower. Next, sag template. What is meant by sag template? So first point, sag template is a convenient way of locating the towers in the field. Then it is drawn on a transparent paper which consists of set of curves. So sag template basically it is drawn on a transparent paper with a set of curves. Next, the horizontal and vertical distances represents the span length and span respectively. So the horizontal distance, okay, represents the span length. Vertical distance represent the sag. Okay. Next, we see how is a sag template. So we see that. So basically, the previous slide mentioned that it consisting of a set of curves drawn on a transparent paper. So we see here on the right side. So the first curve, it is mentioned as conductor line. The next below that clearance line, and the last down one tower footing line. So see that. So these are two supports. These are two supports. Between them, the conductor is suspended. Okay. So that is the how the transmission line. Now see the what is this? There are points. Upper curve is the conductor line. Okay. So that is a, you can see the in the diagram also. This curve is obtained by plotting the sag at maximum temperature against span length. So it is obtained, this curve is obtained by plotting sag, okay, against span length at maximum temperature. It is also called hot curve. It is also called hot curve. Next, middle curve clearance line. Okay, so middle curve is the clearance line. Okay, so then it is drawn parallel to the conductor line. Okay, I'm talking about the second point. So it is drawn parallel to the conductor line and at a vertical distance equal to the minimum clearance of the power conductor and ground. At a vertical distance equal to, okay, I'm continuing this. Um, it is at a vertical distance equal to minimum clearance of the power conductor and ground. So so how much distance? Okay, it is from the conductor line. It is nothing but clearance, minimum clearance of the conductor, okay, from the ground. It depends on the operating voltage according to Indian rules. Then the last one, lower curve, is a tower footing line. This line gives the location of the footing of the tower. Okay, so this line gives the location for the footing of the tower. So here we can see a table which shows the minimum clearance to ground, how much clearance we can maintain. Okay, we know that. So when I suppose there are two supports A and B, a conductor is suspended like this. So this is sag, right? This is sag. Now minimum clearance means this one, right? Ground clearance. So they are telling this value minimum clearance to ground. So for different operating voltages, okay, that value changes. Less than 650 DC supply, the minimum height is 5.8, okay, or to 325 AC supply, okay, it is given as 4.6, okay. Then less than 66 kV, less than okay, that means these values, okay, for the less than 650 DC or 325 AC, okay, volts AC. Next, less than 66 kV, the minimum clearance is 6 meters, okay. Then between 66 110, it is 6.3. Between 110 and 165 kV, it is 6.6. Exceeding 165 kV, it is 6.9. Remarks are across public roads, other positions, inaccessible areas to vehicles. Okay, so these minimum clearance, okay, values are given. Okay, I mean these are the yes, minimum clearance values where, okay, they mentioned it as uh, across public roads, other positions, inaccessible areas to vehicles. Okay, so where vehicles are inaccessible, vehicles are not allowed. So those are the in those areas. Okay, um, so that means these are the specific, these are the remarks. Okay, so so then see that design of transmission tower, design of transmission tower. So what is the total height of the transmission line is decided. So the fact is that they are telling, it is shown in terms of 4 points. The factors governing height of a tower are given. First one, minimum permissible ground clearance. Okay, minimum permissible ground clearance, that is H1. You can see on the right side. And second one, so minimum ground clearance, right? So from the ground. Okay, then then sag, maximum sag. So we know that. So from here to here, conductor is suspended. So this is a sag. So from that point to the down ground, that is a clearance, minimum ground clearance. Next, third point, vertical spacing between conductors H3. Yes, so these are the, it is a three-phase overhead line, right? So vertical spacing, so from phase to phase between the phases, vertical spacing between the conductors, it is mentioned as from first conductor to third conductor H3. Next, vertical clearance between ground wire and top conductor. So we know that this is a top conductor, ground wire is on the top. Okay, generally that is how where the ground wire is placed for the transmission towers, big towers. Okay, so that is H4. So finally, the total height. The total height of the tower is given by H is equal to H1, sum of these four. H1 plus H2 plus H3 plus H4. Next, um, conductors for 400 kV, 220 kV and 132 kV operations. So depending upon the operating voltage, there are types of conductors they use. So in general, that is mentioned like this. Okay, for voltage level 66 kV, for voltage level 66 kV, the type of conductor is ACSR dog conductor. Okay, we'll see next step what is a dog conductor, exactly how many steel strands are there, how many aluminum strands are there. Next, for 132 kV, ACSR Panther conductor, 220 kV, ACSR Zebra conductor, 400 kV, ACSR Twin Bundle Mose conductor. Now, first see the dog conductor. Dog conductor is a ACSR cable, aluminum, we know, aluminum conductor, steel reinforced with nominal aluminum cross sectional area 100 mm square. Okay, it has a cross sectional area 100 mm square. It has 6 aluminum strands. Okay, it has 6 aluminum strands of 4.72 mm diameter and 7 steel strands of 1.57 mm diameter. So that is how this dog conductor, okay, having the steel strands and aluminum strands. Next, panther conductor. Second one, look at the second next conductor. Panther conductor is also a ACSR cable having 7 strands of steel of 3 mm diameter and 30 aluminum strands of 3 mm diameter. Okay, so in general we know that, okay, aluminum strands are more, right? ACSR conductor, how it is? So at the center we have the steel, okay, center we have the steel, outside aluminum strands, right? So that is how outer layer is aluminum. So outer strands are aluminum, which are more in number in general. Okay, so that is what mentioned. Panther conductor having 7 strands of steel and 30 aluminum strands. Next, zebra conductor is a ACSR cable with nominal aluminum cross sectional area 400 mm square. It has 54 aluminum strands of 3.18 diameter and 7 steel strands of 3.18 diameter. Diameter wise, strands is same. Only number of steel strands and aluminum strands vary. Okay. Then fourth one, twin mousse conductor. Twin mousse conductor is a ACSR cable with the nominal aluminum cross sectional area of 500 mm square. Uh, uh, that is a nominal cross sectional area. Then uh, then it has 54 aluminum strands of 3.53 mm diameter and 7 steel strands of 3.53 diameter. So that is about the twin mousse conductor. Then we see what is the current carrying capacity in a table. We see the table here. What is the current carrying capacity? Okay, at 40 degrees Celsius and 45 degrees Celsius ambient temperatures. Okay, for the different conductors. So here first look at the dog conductor. It is for 40 at 40 degrees Celsius temperature. Its current carrying capacity is 324. Next at 45 it is 300. So then wolf conductor. So it is a code name mentioned. So it is a type of conductor. So it has 430, okay, ampere and 398 like that. So these are the its current carrying capacity is mentioned in the table. Next topic is overhead line supports. That means what are the various types of overhead line supports, means in the transmission line, overhead transmission lines, the supporting structure we have. So the what are the various types we can use for that? So basically, what is meant by this overhead line support? The supporting structure which are used for overhead line conductors, such as various types of poles and towers. Okay, so that is the nothing. That is the overhead line support. Okay, then in what are the properties? What are the properties it must have? First one, high mechanical strength to withstand weight of conductors and wind loads. Then second point, light in weight. Okay, first one is high mechanical strength. Then light in weight without the loss of mechanical strength. Third point, cheap in cost, okay, and economical to maintain. And fourth point, longer life, easy accessibility of conductors for maintenance. Okay, these are the main properties, okay, a supporting structure supposed to be. First one, under that wooden poles, okay. So first type of support is wooden pole. So mainly it is used in shorter spans, okay, shorter length. Then used in distribution purpose in rural areas. It is used in distribution distribution lines in the rural areas. Okay, we see on the right side have a wooden pole. So we see in the villages also we can see the wooden poles. In general, so this is shown for different heights. Okay, in the diagram. Now the main objections, there are some limitations of, okay, objections for the wooden poles. First one, tendency to rot below the ground level. So the pole under the ground, it is going to be rotten after some period. Then second point, comparatively smaller life. So it have the smaller life. It is given 20 to 25 years. Next, cannot be used for voltages higher than 20 kV. Less mechanical strength. Less mechanical strength and require periodical inspection. So once in a while it is supposed to be monitored, check, okay, how is the condition, how its condition is. Next type of support is steel pole. Steel poles. We'll see on the right side, okay, on the slide, how a steel pole looks like. Okay, we'll see on the roads also, in the um, in the rural areas, right? Not in the rural areas, sorry, urban areas. Okay, so in the urban areas, so uh, so this is how it looks like. Look at the points: greater mechanical strength, longer life, permit longer spans to be used. Next, second point, used for distribution purposes in the cities. Okay. Third point, this type of supports need to be galvanized or painted in order to prolong its life. Steel poles are supposed to be galvanized or painted to have its life period. Okay, more life period. Next, concrete poles. Concrete poles, which is also mentioned as RCC poles. We'll see in the picture on the right side how a concrete pole we may have. Okay, we you might have seen in the on the roadside. So What are the properties? Its properties, first point, greater mechanical strength, longer life, permit longer spans than steel, last point, little maintenance and have good insulating properties. Okay. Then there is one difficulty. It is mentioned here with the use of these poles, the high cost of transport owing to their heavy weight. Okay, so transport cost is very high because of its very heavy weight, and therefore such poles are often manufactured at the site in order to avoid cost of transportation. Next, next type, steel towers. Okay, we have seen steel poles previously, steel poles, but now steel towers. Steel towers. Okay. Other way they also say it as transmission towers. So you'll see these are the used mainly in the high voltage transmission lines. Okay, we'll see on the this kind of things generally on the highways beside the highway roads. Okay, this kind of towers we'll see. Okay, picture you see in the right side, this diagram shows how it looks like. Okay, the its properties we'll see that here. Okay, so mechanical strength good, longer life, withstand more severe climatic conditions, longer spans, permits longer spans. Now, the main parts of the tower, steel tower. Okay, it of course the tower looks like this. We know here. See that this is a cross arm. These are the cross arms. Okay, then from here to here, body, tower body. Okay, the down one is a tower body. Then on the top, we'll see that here this is called peak. This shaped one, it is called peak, and this one, this cross part, it is called cage. It is called cage. So here, types of transmission towers. Next is uh, just it is self-explanatory, types of transmission towers. So according to the angle of deviation, there are four types of transmission towers. Okay, based on the angle of deviation. A type tower, angle of deviation 0 to 2 degree. B type tower, 2 degree to 15. So like that, C type tower, D type tower is given. Okay, then next point, as per the force applied by the conductor on the cross arm, the transmission towers can be categorized in another way. Okay, force applied by the conductor on the cross arm. Okay, based on that, tangent suspension tower. Okay, tangent suspension tower. It is generally A type tower. Then angle tower or tension tower. It comes under BCD types of transmission towers. Okay, so we see here continuation suspension tower. Okay, the first picture shows the suspension tower. Okay, this first picture. Okay, then tension tower. This is a tension tower. Okay, okay. Suspension tower means just lines are passing. Okay, the lines are passed through the supported using supporting tower through the insulators. Okay, down the insulator, the conductor is connected. Okay, now tension tower or angle tower means next second picture down. Angle tower means see how the conductor is placed. So yes, the conductor is placed in such a way that the insulators are arranged in a manner like this. Okay, these two are insulators connected like this in an angle manner. Between them, through that common point, the conductor line is passing. Next, transposition tower. We know what is meant by transposition. We have seen in the first module, first unit. Transposition means each the position of the conductors are changed. Okay, from time to time. Okay, each conductor occupies the position of the other conductor. Okay, okay. There are three positions, right? The total length L is divided into three parts. Okay, so three positions: position one, position two, position three. So this third picture shows that. So position 3. So each conductor, the position of the conductor is changed. Okay. So it changed from time to time. That is called transposition, right? So this is how the tower is arranged like that. This arrangement. So it is called transposition tower. Transposition tower. Next, based on number of circuits. Based on number of circuits, single circuit tower, double circuit tower, multi circuit tower. We know already. Single circuit means there is only one conductor per phase, right? That is single circuit. We'll see on the right side this picture single circuit, single. Okay, single circuit tower. Next, double circuit line. We'll see next one is a double circuit. Each phase having two conductors. Okay, so these two comes under phase A. Next phase B. Next phase C. Next one, look at the next picture. Single circuit, this is they're telling single circuit, double earth wire. Earth wire is okay, double wire it is. Next, the next one is double circuit. Yes, there are two conductors, right? So it is definitely double circuit, double earth wire. So this one, I think based on this arrangement, the earth wire is okay. So two, it is also here earth wire also double. Two wires are there. Okay. On the top, we'll see there is a, here it is a generally where earth wire is placed. Single earth wire here. But here two options are given for the earth wire. That's why double earth wire. Okay, so there are three more types of towers. Wide V tower. Okay, it is, we'll see here clearly. It is in the form shape of a V. Okay, voltages of 230 to 735 kV. Voltage operating voltages and gate cross rope suspension tower. See, its arrangement is like this. Okay, it's used in 735 kV conductors. The next, last one. This is, I think, the purple. Okay, this is a stay set. Okay, it is a stay set. Okay, that's all. Now these are my references. Thank you for that.
Like, share and subscribe. Hit the bell icon for more updates.